Download this code from codegive.com, link in the description below. OK, let's dive deep into BPEL, Business Process Execution Language, specifically focusing on BPEL 2.0. We'll build a simple process from the ground up, explaining the concepts, structure, syntax, and best practices along the way. We'll assume you have a basic understanding of XML and web services, SOAP, wsdl. Tutorial, BPEL 2.0 from scratch. Part 1, Introduction to BPEL. What is BPEL? BPEL, Business Process Execution Language, is an oasis standard XML-based language used to define and execute business processes. It orchestrates interactions between different web services to achieve a specific business goal. Think of it as a workflow language for web services. Key concepts. Process. The central unit of a BPEL definition. It defines the overall flow of activities. Activities. The building blocks of a BPEL process. They represent tasks or operations within the process. Examples include invoking a web service, assigning a value to a variable, making a decision based on a condition, looping, etc. Partners. The external web services that the BPEL process interacts with. Partner links. The mechanisms by which the BPEL process establishes communication with its partners. They define the roles each partner plays in the interaction. Variables. Containers for storing data used within the process. They can hold message payloads, simple data types, or more complex XML structures. Correlations. Mechanisms to relate multiple invocations or messages to the same process instance. Useful for long-running processes and asynchronous interactions. Fault handling. Mechanisms to handle errors and exceptions that may occur during process execution. Scope. Defines a local context for variables, fault handlers, and compensation handlers. Why use BPEL? Service orchestration. BPEL is ideal for coordinating complex interactions between different services. Standardization. BPEL is a standard, ensuring interoperability across different BPEL engines and platforms. Abstraction. BPEL abstracts away the complexities of the underlying web service implementations. Flexibility. BPEL allows you to easily modify and adapt business processes as needed. Auditability. BPEL processes can be easily audited and monitored. BPEL engines. BPEL processes are executed by BPEL engines. Some popular engines include Apache ODE, a free and open source BPEL engine. Oracle BPEL Process Manager, a commercial BPEL engine. Active BPEL, an open source BPEL engine, less actively maintained. Camunda BPM, a BPM platform that supports BPEL, less common now, often prefers BPMN. BPEL 2.0 versus BPEL 1.1 BPEL 2.0 is the most current version of the BPEL specification and offers some improvements over BPEL 1.1. Improved fault handling. More flexible and granular fault handling mechanisms. Enhanced compensation. Improved support for compensating activities after a fault. Simplified correlation. More straightforward correlation mechanisms. Human interactions. While BPEL isn't primarily designed for human tasks, it can be integrated with human workflow components. Standardization. BPEL 2.0 is an oasis standard. Part 2, Our simple BPEL process, order processing. Let's create a simple BPEL process that simulates order processing. The process will 1. Receive an order request, containing customer ID and item details. 2. Invoke a service to validate the customer's credit. 3. Invoke a service to check the inventory. 4. Assign a confirmation message if both credit and inventory checks are successful. 5. Reply to the client with the confirmation message. 6. Handle faults if either credit or inventory checks fail. Part 3, Setting up the environment. 1. BPEL engine * will use Apache Ode for this tutorial. Download and install it. Refer to the Apache Ode documentation for installation instructions, https://ode.apache.org/ https://ode.apache.org. You'll typically need Java installed. 2. IDE * use an IDE with BPEL support, example Eclipse with BPEL plugin, NetBeans, IntelliJ IDEA with plugins. This will help with syntax highlighting, validation, and debugging. 3. Web services * for this example, we'll assume you have two simple web services. * credit check service, takes a customer ID as input and returns true if the credit is good, false otherwise. * inventory check service, takes an item ID and quantity as input and returns true if the inventory is sufficient, false otherwise. * if you don't have these services deployed, you can create mock implementations for testing purposes, using tools like SoapUI, or creating simple web services with Java, Python, Flask, Django, or other languages. The key is to have wsdl definitions for them. Part 4, Defining the wsdls. Before writing the BPEL process, we need the wsdl, Web Services Description Language, files for the partner services and the BPEL process itself. * credit check service.wsdl * inventory check service.wsdl * order process.wsdl, for the BPEL process itself. Important * replace the location attributes in the service elements with the actual endpoints of your services. These are just placeholders. Part 5, Writing the BPEL process, order process.bpel. Part 6, Defining partner link types, order process.plt. BPEL requires a partner link type definition to specify the roles that partners play in the process. Create a file named orderprocess.plt in the same directory as your BPEL file. Part 7, Understanding the BPEL code. * process element * the root element, defining the BPEL process. Name, target namespace, and XML-NS attributes are crucial. Import elements * import the WSDL files for the partner services and the BPEL process itself. Namespace, location, and import type are important. Location paths should be correct relative to your deployment structure. Partner links element * defines the external services the BPEL process interacts with. Partner link type refers to the partner link type defined in the .plt file. My role and partner role specify the roles each partner plays. Variables element * defines the variables used within the process. Message type specifies the WSDL message type for variables that hold message payloads. Type specifies simple data types, example XSD Boolean. Sequence element * defines a sequence of activities that are executed in order. Receive activity * receives a message from a partner. Create instance = yes indicates that this is the first activity and creates a new process instance. Assign activity assigns a value to a variable. The copy element copies data from one variable or expression to another. The from and to elements use XPath expressions to navigate within the XML structures of the messages. Invoke activity invokes a web service operation. Input variable and output variable specify the variables that contain the input and output messages. If activity performs a conditional check. The condition element uses an XPath expression to evaluate the condition. The then and else elements contain the activities to be executed based on the condition. Reply activity sends a reply message to a partner. Fault name specifies the fault to be returned if an error occurs. Part 8, Deployment and Execution. 1. Create a deployment descriptor, deploy.xml. This file tells the BPEL engine how to deploy the process. Create a file named deploy.xml in the same directory as your BPEL and wsdl files. 2. Package the BPEL process *. Create a zip file containing the order process.bpel, order process.wsdl, order process.plt, credit check service.wsdl, inventory check service.wsdl, and deploy.xml files. You can name the zip file order process.zip. 3. Deploy to Apache ODE *. Deploy the order process.zip file to your Apache ODE engine. You can typically do this through the ODE web console or using the ODE command line tools. Refer to the ODE documentation for deployment instructions. 4. Send a request *. Send a SOAP request to the order process service endpoint. You can use a tool like SOAP UI or write a simple client program to send the request. Here's an example SOAP request. 5. Check the response *. If the credit check and inventory check are successful, you should receive a SOAP response containing the confirmation message. If either check fails, you should receive a SOAP fault. Part 9, Fault Handling, Enhancement. Let's add more robust fault handling to our BPEL process. We'll use a scope activity to define a local scope for fault handlers. Scope activity defines a local scope for variables and fault handlers. Fault handlers element contains a list of fault handlers. Catch element catches a specific fault. Fault name specifies the name of the fault to catch, example pull remote fault for service invocation errors. Catch all element catches all faults that are not caught by other catch elements. Part 10, Compensation, Brief Overview. Compensation is used to undo activities that have already been successfully completed if a later activity fails. It's crucial for long-running transactions where you need to maintain data consistency. BPEL provides compensate activity and compensation handlers within scopes for such scenarios. Implementing compensation in this simple example would add significant complexity and might involve more sophisticated mock services with rollback capabilities. Part 11, Correlation, Brief Overview. Correlation is used to associate multiple interactions with